Well, hello, everyone, and thank you for joining the August 2023 VMware TAM Customer Webinar. The VMware Customer Success Organization hosts this webinar to allow you to interact directly with great speakers on topics that will help you maximize your VMware investment. Before we get into today's content, just a couple of basic announcemements. Our next TAM Customer Webinar will be on September 14th on the topic of ARIA Automation Config, perhaps still better known as Salt Stack Config. So depending on your ARIA licensing, you may already have access to this solution, and we want to make sure that you understand the value that it can provide in the area of configuration management. If you have any questions during today's webinar, please use the Q&A feature of Zoom, and we'll address them during the webinar. And if your question does not get fully addressed, then please follow up with your TAM, and they'll work to get it answered. At the end of today's session, you will be prompted to fill out a simple 2-question survey related to the value you receive from this session and any topic suggestions for future sessions. We value your completion of the survey to keep us pointed in the right direction going forward. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you. After a few months, the recording does become publicly available on the VMware TAM Services YouTube channel, where you can view any of our webinars from the past several years. So that brings us to today's speaker and topic. A key part of VMware's strategy is that the VMware software-defined data center stack is running in a variety of environments, including all the major hyperscalers. Each of these public cloud implementations has their unique characteristics, and Pratik Jain is going to help us understand what those are for the Oracle Cloud VMware Solution. Pratik, I'll turn it over to you now.
Thank you, Andy, for the introduction. My name is Pratik. I'm a senior cloud solution architect with VMware, majorly working on Oracle Cloud VMware Solution. So we're going to talk about today on Oracle Cloud VMware Solution and how it fits in the VMware multi-cloud portfolio, where we enable customers to run any workloads on any cloud. And so we're going to talk about the solution overview. How does Oracle Cloud Solution looks like, the salient features of the solution, the use cases that the solution can achieve. How do we, once we have looked at all the features, how do we migrate and see moving workloads from on-premise or other cloud providers to Oracle Cloud, and general networking. How does the networking portfolio looks for Oracle Cloud VMware Solution, and some customer success stories with Q&A. In this session, we generally would, I would take questions at the end of the session. As Andy said, you can put the questions in the Q&A, and I would be happy to answer them. In case you need any information directly or detailed discussion, feel free to reach out to me, or feel free to reach out to your TAM, and we can set up a detailed discussion. So let's take a look at what Oracle Cloud VMware Solution is. Now, Oracle Cloud VMware Solution is a first-party service which sits in OCI. So OCI, this Oracle Cloud Infrastructure is a second-generation cloud built by Oracle. OCI has all the services that you need to build, run, migrate all your IT infrastructure, along with your VMware estate, and bring all your enterprise workloads from cloud-native applications and data platforms to OCVS and OCI. Now, what is OCVS? OCVS brings the VMware enterprise class software-defined data center to Oracle Cloud. Now, Oracle Cloud VMware Solution is commonly known as OCVS. Now, OCVS, what it does is it enables customers to accelerate their cloud migration simply, quickly, and with a low risk and a compelling TCO. Now, how does it do that? Basically, what OCVS is, it's a replica of your on-premise software-defined data center running in Oracle Cloud. When I say replica, in Oracle Cloud basically gives you the complete control and the complete management of your software-defined data center, even though it's running in the cloud. With the OCVS, you would be able to get the root credentials and full administrative control of your entire fleet of SDDC, which is running in cloud. And when I say complete control, you would have the admin credentials for the vCenter, the root credentials, along with the root credentials for the bare metal ESX hosts, and the NSX managers and edges as well. So if you have a custom configuration, custom solution, any advanced settings which you have done based upon your experience of running workloads on your VMware estate in your on-premises, and you want to migrate the workloads to the cloud, and with the configuration, customized configuration that you've done on-premise, you can do that in OCVS as well. So basically, OCVS is nothing but the VMware software-defined data center, which is the virtualization is provided by our vSphere solution. Then you have vSAN for storage virtualization. Then you have NSX, which provides the network overlay and networking functions for your workloads. Then we have VMware HCX. HCX provides you the mobility platform where you, if you want to lift and shift workloads from your on-premise to cloud, or you want to migrate them back from cloud to on-premises, or you want to do cloud to cloud migration. If you have a different VMware-based subscription on clouds like Azure, Google, or AWS, and you want to migrate workloads from there to OCVS, you can still use HCX to do that. With OCVS, because OCVS runs in the same network, as in the same tenancy as Oracle native services. So you have a direct attachment and direct access to any amount of OCI native services, be it autonomous databases, ERP, CRM, any other applications that you use on day-to-day basis from Oracle. Now, it is just not the VMware SDDC stack, which comprises of vSphere, NSX, and vSAN. You can have any number of solutions like the complete ARIA suite, Horizon, Site Recovery Manager for your disaster recovery management, and VMware Tanzu for application modernizations on OCVS. These are all the solutions which are interoperable, and we will talk about them in detail in the upcoming slides. Now, Oracle has 45 locations. 45 regions where OCVS is generally available. And Oracle, in a partnership with VMware, what they have done is when Oracle launches a new region, OCVS is available as a service from day zero. So as a customer, you do not have to wait for the service to come up. Recently, Oracle launched a region in Canberra, Australia, and the OCVS is available from day zero in that region. So all in all, Oracle treats the VMware service as a first-party service, and they do not have any differentiation between the services in all regions. Now, while we have 45 regions, we have 12 Azure interconnect regions available with OCI as well. So what these OCI interconnect does is using your Oracle Fast Connect and the Azure Express route, you can set up a private interconnection between your OCI and Microsoft Azure environments. And these interconnects can help you to set up a unified identity access management platforms. You can set up SSO between Azure and OCI for integration of Oracle applications like PeopleSoft, e-business suites, and anything else that you use from Oracle. Now, the good part is there is a direct connection between vendors, so between Oracle and Microsoft. So you have less than 2 milliseconds of latency, which is for enterprise, good for enterprise customers. And the pricing is solely based on the port capabilities. There is no charge for inbound and outbound data bandwidth consumed between Azure and OCI. So while it gives you the complete flexibility to have your identity management platforms running in Azure and your workloads running in OCI or on OCVS. So this is how the general architecture of OCI region looks like. So you have multiple geographical locations. We have locations in regions in North America, Europe, Asia Pacific, India, Australia as well. And in all of these geographical locations, you have multiple regions. So as of today, we have 45 regions. And each of these regions would have different availability domains. Now, while Oracle, there are some regions with 3 availability domains. There are the newer regions which are coming up. They are coming up with 1 availability domain. But what Oracle has done differently is that in each of these availability domains, while you have a single AD or availability domain, they have multiple fault domains. So that A fault domain gives you a grouping of hardware and infrastructure within an availability domain to provide you a higher degree of protection. And it generally works like a different uh, availability domain as well. So let's assume you deploy a bare minimum 3-node OCVS SDDC. In that 3-node SDDC, all 3 hosts will be running in separate fault domains. So while you have vSphere HA protecting your workloads, even if there is a fault domain for failure, or if there is a failure on the underlying infrastructure, you would still be protected by the salient features of the fault domain, which are available in OCI. Now, most of the OCI services are global, but the compute services, DB systems, block volumes are all regional services. So, and your accounts are mostly configured by the region which is default allocated to you, but you can always subscribe to other regions as well. Now, while Oracle has all the regions, there are different models and different delivery options available for OCVS as a customer. While you have public cloud regions for the 45 regions that we already see, we have government regions as well, and then EU sovereign regions where there is strict data protection policy because of the government and all the government specific certifications are there applied on the infrastructure, and for the EU sovereign regions as well. Now, apart from this, there are 2 other ways that we have possibilities of consumptions of OCVS. One is a dedicated region. And dedicated region is nothing that we call as dedicated region clouded customer, which is basically where Oracle would come in and install the entire cloud region on your on-premise data center behind your firewall. You would be using the complete cloud capabilities of Oracle Cloud, including OCVS over there. You can use 100% of the capability for OCVS in that region, and but it would be sitting inside your data center. So if you have a very specific application, very specific workloads that require to be on-premise, yet you want to use the flexibility of cloud, DRCC is one such available option available for us. Then we have isolated regions, which are very specific regions which are in customer realms, but defined by the compliance is defined by the customer. And there are dedicated ops teams which are there for clearance at the customer. The last and the most important one is Alloy, right? The Alloy is basically a multi-tenancy feature provided by Oracle in OCI, where as a partner, you can have OCVS made available to other customers, and Alloy gives you that multi-tenancy feature in OCI to provide you resources and have you onboard customers on cloud, be it for a partner, it can be for your internal consumers inside your organization, or for any other use cases as well. So let's take a look at while we've looked at what the OCVS solution looks like, and let's look at what are the differentiating features which Oracle Cloud VMware Solution has. Now, some of the Oracle Cloud has 2 types of shapes which are available as of today. One is the dense IO shape, which is the dense compute shape, and then we have standard compute shapes as well. There is a possibility of single node. We have OCI file and block level services, shielded instances, multiple interoperable VMware solutions, and GPU support for OCVS. So let's take a look at the dense IO shapes. So the dense IO shapes are the stuff. Were the shapes which are available until earlier this year. They are still available as of today. There are 2 types of shapes which are available. One is Intel, one is AMD. The Intel is a 52 core, 768 GB RAM, and each node provides you a 51 terabytes local NVMe storage. So if you build up a 3-node cluster for Intel, you would get around 156 cores and approximately 120 terabytes of usable vSAN data store, where because it's vSAN enterprise, you can use any amount of fault tolerance policies. You can customize vSAN as you like it. And whatever you have been using on premise, you can still use that capability in OCVS for vSAN. Then we have AMD shapes. Now, Oracle is the only hyperscaler as of today, which is providing AMD shapes. AMD shapes are available in 3 variants. We have 32 cores, 64 cores, and 128 core node. 128 core node is the largest size node which is available. Each of these nodes are 2 terabytes of memory and have 54.4 terabytes of local NVMe storage. So they are quite dense, and that's the naming convention, dense IO. And each of you have capability and capacity in a minimum 3 node cluster, which is required for vSAN to run any VDI workloads or memory intensive workloads or workloads which require higher storage in these compute shapes. And then we have these new shape agnostic shapes, which are shape agnostic compute shapes, which are standard shapes, which we call, which have been recently launched. Now, these standard shapes, the only difference between these compute shapes and the standard, the dense IO shapes and the standard shapes is that there is no vSAN in it. It is completely backed by your choice, where you can have OCI block storage or OCI file storage. If you have workloads which require file storage services, then you can consume file storage from Oracle, add that as a NFS data store onto your hosts. If you require a VMFS data store, then it would be iSCSI back data store, which would be provided to you, and you can add that as a standard data store, how we add in our regular VMware infrastructure as of today. Now, that is a differentiating feature in terms of storage. The major differentiated feature which comes in these shapes is the how the core agnostic they are. So you can have a single, as in you can choose how many bare CPUs do you need, or Oracle CPUs. So you can start from 16 and go from 16, 32, 48, 64 on an Intel node. And then for AMD, you can go from 32 to 128 in terms of 25%, or you want to use 50% of the capacity or 75%. And you would be built according to what you're using. So if you use 16 core of a 64 core node because you chose that while you were deploying it, then you would only be built for 16 core. You would get the same amount of memory, same amount of the storage would be there because you would be using block storage. And then these would have 2 NICs of each of 50 Gbps. And Oracle is coming up with options to scale with the expansion packs, where you would have capabilities of moving up. So let's say you have a 16 core 3-node cluster, your requirement to run workloads increase, and you want to move from 16, rather than deploying a new cluster, you want to increase the capacity of this cluster itself. You can move from 16 to 32 or 16 to 48 or 64 as you want, and your pricing entitlement would change. So yeah, so this is how the differentiation looks like, the standard compute, the dense IO shapes and the standard shapes. The only difference being the one major difference, other difference in the pricing is that in the standard shapes, why you do not have monthly commitment available. It's only hourly, 1 year or 3 year commitment. While in dense IO shapes, you would have hourly, monthly, 1 year and 3 year commitments. The rest all remain the same. Single node SDDC is nothing where we provide you a proof of concept SDDC, where you would get a similar or production like SDDC, which would be running on a single node vSAN. Now, because it's backed by vSAN, and that's how we create a single node SDDC, this option is only available with dense IO shapes. It's not available with, as of today, it's not available with new standard shapes. You would get the complete look and feel of how the OCVS SDDC would look like with the complete access, but it is only available for limited support with 60 days. There is no SLA bound. If the host fails, the data is gone because of vSAN being there. You can, if you require a long-term SDDC, you would have to still move your workloads using HCX from this SDDC to the another SDDC, and which Oracle provides value-added services called Oracle Lift and Shift services, where they would help you move workloads from a POC single node SDDC to production SDDC. Now, these SDDCs can be used for anything. You can use it for POCs, you can use it for testing, development, UAT, and any amount of use cases that you can think of. But as I said, it's only limited for 60 days. Then this another salient feature is the external storage. Now, Oracle provides you two types of storage, as we talked about, the being the backbone of storage in the new standard shapes. It provides you NFS version 3 file storage services and block storage services. Now with block storage, you can use the complete, because it's vSphere Enterprise license, which is there in Oracle Cloud VMware Solution. You can use, you can create multiple data stores. You can have SDRs configured on that data stores for management of your, for balancing of your workloads on the storage. You can create a data store which is up till 8 exabytes. You can increase the space of the storage on the fly, like you do it in your on-premises SDDC, and you would only be billed for what you use, right? So if you, let's say you have provisioned 100 terabyte data store, but you're using 50, you would only be billed for the 50 terabytes that you're using. So this option is also good for customers who have a 3-node cluster running dense IO shapes, very storage heavy applications. If you do not need to add another host in the cluster just to consume vSAN storage, you can add a file level data store, a NFS data store, or a VMFS data store from OCI, and save the cost as compared to node to storage. So you can look at that. So that's one of the features that OCVS has. Now, shielded instance is another feature where basically it's a combination of your secure boot and TPM. It helps you harden the firmware security of your ESX instances. And this is to provide additional layer of security on Intel hosts to have any signature checking for your drivers, firmwares, any amount of applications. Because, and this feature is important because if you look at it, as you have the root access of the ESX host, you have the complete control. It provides you additional layer of security so that inadvertently as well, you're not installing any unsigned drivers or any application which can cause a destruction to the ESX host. So it provides you, and then it also gives you options to store vSAN encryption keys on the hypervisor TPM device. So if you're using KMS or vSAN encryption, you have options to use that as well. Now, these are all the additional VMware solutions which are available with OCVS as of today. You have VMware ARIA management and automation, the entire ARIA stack, starting from ARIA operations from networks to ARIA operations for logs, and ARIA automation as well. Then you have the VMware Horizon platform. You can integrate your on-premise Horizon deployments to your OCVS SDDC and have load balance your Horizon workloads from on-premise to cloud. You can build up a new environment of Horizon in the OCVS SDDC itself and have any amount of apps, devices, desktops, scale and managed in the cloud. Then you have AVI load balancer, the NSX advanced load balancer, which is available in OCVS. Tanzu is there for application modernization and enterprise running of enterprise grade Kubernetes runtime applications. Then you have site recovery manager. One of the major use case that we see along with the customer is to have a DR on cloud. And with OCVS providing you very small shapes, which is 16 core, you do not have to spend on a bigger node shape to build a DR. So ideally what you can do is you can build a 3-node cluster, a 16 core 3-node cluster, configure site recovery manager to replicate your workloads and configure replication plans as we do today as well. And once you have a DR, you can scale up your existing OCVS SDDC up to 64 hosts or build a OCVS SDDC, which takes approximately 1.5 to 2 hours and scale it accordingly. So if you can have a small DR and scale your DR as you require. So if you have a simulated DR, then you can plan it accordingly. If you have actual disaster on your production SDDC, then because your workloads are being replicated and protected on the cloud, you can just build and scale your DR. Then you have VMware Cloud Director Services, which is which provides you multi-tenant services to for your tenants and LOBs for with complete separation and control. Last and the most differentiating feature, one of the most differentiating feature which is there and which is not available in other hyperscalers as well, is the NVIDIA GPU. Now, this is currently in beta, but it's available for customers to consume as well. You can have NVIDIA as in OCVS shapes with NVIDIA A10 Tensor GPUs. Each of these nodes would have 1 terabyte of memory, 100 Gbps of network bandwidth, and very small 7.68 GB of raw NVMe storage, which would form a local store data store on that. And then you can integrate your OCI file level or block level services to have additional storage on that. Now, because Oracle has a differentiating model where Oracle provides you the complete access and the complete management and the capability of OCVS. This is how the responsibility model as compared to other hyperscalers is different. In Oracle, the complete management and the complete responsibility of the SDDC, the OCVS SDDC, lies with you. You would do the management, the password management, any amount of key management that you have integrated, upgrades, patch management. So if you have a legacy application which is only compatible with 7.0 update 3, or and you want to continue staying on that version, OCVS is a perfect solution for you, because you can continue to stay on that particular version until you see fit. Oracle would not push you for an upgrade unless and until it is specifically triggered by you. You would have to trigger the upgrade and you have the complete control on that. So once the Oracle OCVS SDDC is deployed, Oracle shifts the control of that SDDC from them to you. You can change the passwords on the whatever is displayed on the console with the default passwords, and Oracle would not have any control over the SDDC itself. And then you would have the general responsibilities which all of us have in a general hyperscaler environment for authentication, applications, backups, antivirus, operating system management, and others. But in addition to that, you have to because it's your control environment, you would have to manage the SDDC lifecycle as well. And then Oracle manages all the underlying infrastructure, the hardware, compute, storage, the physical infrastructure, availability domain, and all of these services which Oracle provides are backed by a availability SLA and as well. So they have a performance SLA for network, they have a performance SLA for bare metal nodes and other things, but they have a availability SLA as well. So in a nutshell, Oracle has all the key features which are there, along with the differentiating features in comparison to other hyperscalers, to run your workloads securely and move your workloads without any risk to OCVS. You have as an HCX to migrate your workloads from on-premises to cloud. You have Site Recovery Manager to build disaster recovery on cloud. You can use any amount of other solutions as well, like Veeam, Zerto, any integrations that you have done as of today, which is outside of Site Recovery Manager as well. You can use that with OCVS SDDC as well to build a disaster recovery solution. The most flexible options for nodes are available in SDDC, OCVS, because you have the smallest node, which goes from 16, and the highest node AMD, which is 128. So depending upon the workloads that you want to move to the cloud, or you want to build the new workloads in the cloud, you have flexibility to choose the node that you want. Completely managed and controlled solution by you, so you don't have to rely on the managed service provider or the cloud service provider to do any changes. Whatever changes, APIs, homegrown solutions, anything that you have built as of today in your on-premises, and you want to just do a lift and shift, you just have to make sure that the same role-based access control model is shifted to OCVS, and you can integrate those services as is on the OCVS SDDC as well. And that's reason OCVS, we call it as a true replica of your on-premises. And then you have consistent operations and low cost. And this is one of the other features that Oracle has. Oracle provides consistent pricing worldwide. So it doesn't matter if you're running workloads in US, UK, Europe, or APAC. The pricing for OCVS nodes worldwide is the same, and it's similar to all other OCI services as well. The another key feature is that the inbound data transfer, while it's free with it's free. OCI offers 10 terabytes of outbound data transfer per month at no on the tenancy. So if you have applications which are doing communication, have high amount of outbound data transfer, you have 10 terabytes of outbound data transfer free. And you, with any whatever solution, third-party solutions which you have integrated as of today in your on-premises, or there are different ISVs who are building solutions for vSphere or your VMware SDDCs, those solutions can be integrated with OCVS as well. So there is no mismatch in terms of, because you have the complete control, you can build and attach the solutions to OCVS. And then you have all the required government certifications, HIPAA, PCI DSS, SOC certifications, which are required to run compliant US government compliance or EU compliant workloads on OCVS as well. So let's take a look at what, while we look at all the features, let's take a look at what use cases does OCVS brings in. We have talked about dedicated with customer control, how we can migrate and workloads from on-premises to OCVS. How does OCVS brings in lower TCO because of, and then what all other Oracle services that you can consume to modernize your IT infrastructure. So as we have mentioned multiple times, the OCVS is a complete, as in it has the complete control lies with you and the complete management lies with you. So you have dedicated servers to run your VMware workloads. You have your own virtual cloud network on which the your OCVS SDDC would be deployed, giving you the full control of your VCN, the virtual cloud network, which we call it, the distributed router, which requires the function from transmitting your traffic from OCVS to outside or to any other OCI native services. Then the T0, T1 routers, which are there in OCVS, the NSX DFW modules, you would have complete access. And you can integrate your own IPAM solutions onto OCVS SDDC and have complete control of your infrastructure. And if there is a compliance reason to have complete, as in if you're running a secure workload where you want the control of the underlying infrastructure as well, and the requirement set by the security is such that, then OCVS fits right in that particular bucket. Then you have just VMware faster migration. So what it does is that you have basically means is that you, with HCX, you can, because it's a VMware based SDDC, you can use HCX to migrate workloads from your on-premises to OCVS or vice versa as well. Now, if you look at it, you can OCVS from a OCI perspective, a VCN creation generally takes about 2 to 5 minutes. You can configure IPsec VCN VPN from your on-premises SDDC to Oracle Cloud VMware Solution. Create your OCVS SDDC in 1.5 to 2 hours, which approximately the time it takes depending upon the nodes that you've added, but at a max it takes 2 hours. Once you have configured HCX, you can start migrating workloads within a day. So you don't have to worry about procuring new hardware. If you have requirement to scale up on the cloud or scale up your environment rapidly, then OCVS can help you migrate and scale your infrastructure right away in a single day. Then OCVS also has the lowest TCO. So if you compare, because of the dense shape structure there and the flexibility of compute, which is being provided by Oracle, and the 10 terabytes data transfer free, which is there every month, OCVS has the lowest cost per on the network usage. It has the lowest cost per host as compared to other hyperscalers, along with the lowest cost per storage as well, because it gives you higher amount of storage per host where you don't have to add on another host in compared to other hyperscalers where they have less storage or smaller capacity of NVMe drives. And then last not the least, with if you have applications running on OC Oracle Cloud VMware Solution, you can run any amount of you can consume any amount of native OCI services to have your applications connect to them. So because it's all of them run in the same virtual cloud network, there would be a low latency backbone network connectivity between your OCVS subnet or Oracle OCVS workloads to your OCI services. And all these services would be readily available for you for consumption. Now, these are all the use cases that we generally see customers coming up or customers looking up for while they build their infrastructure in cloud. One of the most used feature is cloud migration, right? Where everybody is looking to adopt cloud, move their workloads, scale up their infrastructure, and or decommission their existing data centers, legacy hardware. OCVS can fit in right in that solution where you can vMotion, do a cold migration, vMotion, depending upon what version of what HCX capabilities that you have, the licensing that you have, advanced or enterprise. HCX by default comes advanced in OCVS. You can upgrade it to enterprise, and you can start migrating your workloads from on-premises to OCVS. It can be any amount of use cases. If you want to do a business expansion, if you want to do to increase the flexibility and agility of your infrastructure, OCVS is the solution to look at. Then one other solution, the one we have talked about this with the data center extension. If you want to extend your data center in burst periods, right? You have a specific requirements in the month of in holidays or maybe at the time of taxation, right? Depending upon what your organization is doing, you can meet those capacity needs with OCVS. So you can build a solution depending upon how much amount of infrastructure do you need. It can be as small as 16 cores, as high as 128 cores, and you can connect those SDDCs using HCX, Fast Connect, IPsec VPN, and start moving workloads or balance your workload so that your application and your infrastructure is ready to handle the business expansion in specific periods of year that you're looking for. And then DR is one that we already talked about. Site Recovery Manager is our standard solution with vSphere application that we provide with OCVS. There is tight integration of SRM with Oracle Cloud VMware Solution. You can either build your production on cloud, have a disaster recovery set on premises, or do the reverse as well. Why? And the reverse is what we usually see customers coming up. They want to set up a low cost, resilient DR on cloud, where you can meet your RPO and RDO requirements. You can have a secure zero trust infrastructure running in cloud, and you do not have to look at maintenance of the hardware, the maintenance of how the infrastructure is looking at, because Oracle would do all of that for you. And the business continuity would be maintained because all your workloads are being replicated to the cloud. The last and one of the what we are seeing is application modernization. Now you can have VMware Tanzu standard is available with OCVS as an add-on solution. You can have Tanzu Mission Control, where you can control your Tanzu clusters running on OCVS or OKE or any other public cloud. And you can have a simplified Kubernetes deployment and container-based workloads running in Oracle Cloud VMware Solution. And the solution is, while OCVS is sold and maintained by Oracle, any add-on solutions that you purchase, be it Site Recovery Manager, Tanzu, Horizon, that would be all be managed by, supported by VMware. And then virtual desktops. So this is Horizon view, where you would have Horizon desktops running in the cloud. We have seen a spurge of work from home requests post-COVID, between COVID periods as well, where there is a requirement to have secure desktops or secure access to your infrastructure provided to end users or your organization employees. So this particular solution gives you a end-to-end, and because OCVS gives you the similar kind of experience for your administrator as well. It's no differentiation, right? However he was managing your Horizon resources on premises, he would have to use the same skill set, same resources, similar methodologies to manage Horizon workloads in the cloud as well. And you have the flexibility to move workloads, load balance workloads between on-premises and cloud. So while we've looked at all the features and all the solution overview, let's take a look at how do we migrate to Oracle Cloud. Now, VMware HCX is a standard mobility platform which is provided by VMware, which helps you migrate workloads as you require. Now, when I say as you require, as per your ease, there are different versions and different features of VMware HCX which are available with OCVS, and because HCX is a commonality with different other multi-cloud partners as well. Similar features are there in others as well. So with HCX, you can do a code migration, migrate powered off VMs from on-premises to cloud. You can do live migration with vMotion, HCX vMotion. You can do bulk migration with a reboot, where you would select a couple of VMs. They would be replicated across to your OCVS SDDC, and then when there is a switchover window, whatever the switchover window that you've configured, the VM on the source would be shut down and the VM on the destination would be powered on. And then you would have replicated assisted vMotion. You have OS assisted vMotion as well, where you can migrate your bare metal servers, KVM, Hyper-V, Red Hat Enterprise Linux servers to Oracle Cloud VMware Solution. While you do migration of workloads, there can be a requirement where you have some dependent application of that workload running on your on-premise, and you would have a requirement to extend your layer 2 network to the cloud. And HCX provides you that capability as well. HCX lets you create a network extension from your on-premises to the cloud. And for that particular network extension, you can, because it's managed by an appliance which HCX automatically deploys, you can have network extension high availability as well. You can, and because to avoid any tromboning effect because of the gateway being running at the source or the on-premises, there is a availability, or there is an option called as manage mobility optimized networking. Now, what mobility optimized networking does is that it basically creates a local gateway. So if you have any workloads which have to intercommunicate in the same segment, that the packet would not be transmitted to your on-premise, it would be routed within the T0 gateway that you have, and it would reduce the amount of traffic coming to on-premises. So HCX all in all gives you the complete flexibility and features to help you migrate workloads from on-premises to cloud, and you can use the same features to migrate them back as well. So it's not a one-way migration. You can do reverse migration as well, and you because we call it a lift and shift, the MAC addresses, the IP addresses, it would be retained as is unless and until you specify to change those MAC addresses and IP addresses. The virtual machine is migrated as is. It's a simplify. It's a what you can say is it's a more distinguished way of doing vMotion. So if you're doing a cross vCenter vMotion or a long distance vMotion from your one vCenter to another, HCX basically uses the same capability with some add-ons in the background to migrate your workloads from on-premises to cloud. And these are the differentiations which are there between HCX Advanced and HCX Enterprise. HCX Enterprise basically gives you replicated assisted vMotion and some traffic engineering, mobility optimized networking, and if you want to migrate your physical workloads, RHEL, Hyper-V, KVM workloads to vSphere, specifically to OCVS, then you can use that as well with HCX. Now, we have all looked at how OCVS is, what are the features, what are the differentiating features. Let's take a look at the generalized architecture of how OCVS in general looks like, and what are how the networking of Oracle Cloud looks like. So this is how the OCVS networking architecture look like. So you would have the SDDC, which you can see down below. You would have the virtual machines, which would get connected to your tier 1, then to your tier 0. Then they would get connected to your VCN, which would have your DRG, as in the distributed router, and or your NAT gateway if your traffic has to go to the internet, or to your service gateway if your application has a requirement to connect to any of the native OCI services. So it exactly looks like your on-premises SDDC. This is and you can have routing table set, route table security groups created in your OCVS SDDC or on the OCI layer to route traffic as you require. So you can have public subnets where your load balancers, Bastion servers or jump servers or web servers would run in. You would have private subnets where your autonomous databases, Exadata and Access database services would run in. And then you would have Oracle services network where your IAM, vault storage, uh, big data, any other services would be running. So the first step uh, in deployment of OCVS is to create a OCI tenant. You first create a tenancy. Once a tenancy is created, you create a VCN. Once the VCN is created, it's basically a virtual private network set up in OCI. It's basically like a standard traditional network where you would have specific firewall rules, a zero trust network, and you enable any amount of, you set up right firewall rules to allow traffic or deny traffic based upon your use cases. And then you create OCVS. So once the VCN is created, the next step is to create OCVS, where you would choose what VCN then you want to attach it to. And it would basically you would need a NAT gateway, because if you want to activate your HCX, you require connection to the internet. So you would need a NAT gateway to be created, or you require the downloading of patches or any updates to using your VLCM onto the VC, or downloading of VC patches as well. So internet gateway, the NAT gateway would provide you that internet connectivity. And then for connection of your connection to your on-premises, right? So for on-premises, how the traffic flow would happen is that any virtual machine sitting inside your OCVS segment or the OCVS infrastructure, they will first communicate to your tier 1, then to your tier 0, and then it would go to the distributed router. If you have a firewall in front of it in terms of firewall, DDoS protection, basically whatever your landing zone has, it would connect to that. And using Fast Connect, it would get connected to your on-premises. And this is on Fast Connect. If you have a IPsec VCN, or if you want to connection over the internet, then it would go basically through the NAT gateway. For any amount of connections to the native OCI services, there is a service gateway which is automatically created. You can write specific firewall, specific route rules on your service gateway on the OCI layer to make sure the communication from your OCVS segment happens to your OCI native services. And you can have the traffic protection done by VMware distributed firewall, which is provided by NSX, or you can have any amount of firewall rules written on the service gateway as well to restrict traffic communication and have a complete zero trust infrastructure set up on OCVS. And then the connection to internet. So the connection to internet happens over the internet on the NAT gateway. It doesn't go through the DRG. The DRG connectivity only happens when your connectivity has to go to your on-premises, or it is via Fast Connect. But if in case there is traffic which is outbound towards the public internet, then it would go through your internet gateway. So it can be any amount of services. It can be load balancer, Bastion servers, web servers, or any other native OCI services that you have consumed that requires that is facing internet traffic. It would come through your internet gateway. Yeah. So this this is all the generalized view that we have for OCVS. Let's take a look at a couple of customers who have successfully adopted and are running OCVS in their environments. We have customers from TIM Brazil to Prophecy International. Then we have Cybereason, Maxim, multiple customers in the other slide. And so Prophecy is one of our reference customers where they are ISV who build products on related to real-time analytics and big data processing and event logging software. So they have a software called Emite and Snare, and they run their entire infrastructure. So they started off their story with running on DR on OCVS, but they were able to move and lift and shift their workloads to Oracle Cloud VMware Solution because they have services which are running in OCI, database services, ERP, CRM, and others which they require close proximity as well. So all their VMware-based workloads were moved from on-premises to OCVS, and they were able to improve their backup speeds, their disaster recovery intervals, and remain compliant with the policies set forth by the organization, as well as government policies for having a disaster recovery site on OCVS. So, and one of the other features that they quickly adopted OCVS is because it gave them a higher version of vSphere, because we have vSphere Enterprise, vSAN Enterprise, NSX Enterprise running in OCVS. So it gives them higher version of software licenses. And so any amount of restrictions that they had because of software licenses that they had on premises, that was moved away with OCVS. And then we have Fuji. So Fuji is one other customer that we have. So they moved their Oracle VMs to make sure from on-premises to OCVS to make sure they do not have a cloud lock-in. They wanted to stick on to VMware. They wanted close proximity to Oracle. So what they did was essentially is they moved their workloads from Oracle VM to OCVS, and they reduced their database operation cost by 1/3. They were able to spread as in operationalize their workloads and do a more visible management of their workloads with OCVS. So, and the last, one of the other reference customers that we have is TIM Brazil. TIM Brazil is a telecom service provider in Brazil. They were able to move their entire VMware infrastructure, VMware estate within a couple of months using HCX to OCVS. So one of the only telecom service provider where they are running the entire workloads on Oracle Cloud along with Oracle Cloud VMware Solution, and their entire IT workloads runs on OCVS. So the majority factor they chose OCVS was to have built a disaster recovery site on DC on cloud as well as DR on cloud, and have a close proximity to Oracle workloads as well. So let's take this is the last slide. I just wanted to recap what Oracle gives you. Oracle gives you, and Oracle in specific, Oracle Cloud VMware gives you fast and seamless migration with HCX. The complete control of your infrastructure with flexible options to deploy nodes as you like. The higher security level for running any workloads with the industry standard certifications, with the complete modules of and the protection layers of NSX DFW plus the OCI network services and your DRG and the security groups that you have. You can modernize your applications and scale. Either you use the OCI native services for databases, or if in case you're modernizing your applications and building microservices, you can use VMware Tanzu, and the pricing is consistent worldwide. So there is no difference in prices. These are all the resources which are available as of today publicly for Oracle OCVS. And that's all for today.
Awesome. We've got a few questions. Could I bring those to you?
Yeah, sure.
Yeah, so the first one is, can I send Oracle PCA VMs to the OCI cloud using OCVS?
I'm not sure. I'm not sure I understand what PCA is. If whoever has asked this question, could you describe what do you mean by PCA?
All right, so Thiago, if you're still on and can follow up, we'll move on to the next question, and then maybe you could provide a little clarification there, okay? So the next one, who provides VMware product licenses in the OCVS model?
So Oracle provides all the licenses. So when you deploy a OCVS SDDC, the vSphere, vSAN, and NSX license are included in the bill of materials. You don't have to worry about the licensing for these three products. If you bring on any add-on solutions like Site Recovery Manager, ARIA, NSX Advanced Load Balancer, or Horizon for that matter, those licenses would have to be managed by you and procured by VMware directly. But for the SDDC, the bare minimum SDDC of vSphere, NSX, vSAN, that is provided along with the cost of OCVS, and that's included in the cost.
All right, perfect. Please share more details on Fast Connects. Does OCVS costing include Fast Connect? How about the bandwidth offerings?
So OCVS does have a bandwidth of 1 Gbps, 10 Gbps as well. The pricing does not include the cost of Fast Connect. But Oracle, what they have done is they have consistent pricing. They do not have bandwidth usage charges. You can look at, I can share reference articles from Oracle where Oracle has compared as to how their Fast Connect helps you save network bandwidth costs. But and it's a static cost per port per month.
Okay. And then what about the support model? You mentioned VMware support for the application level solutions. What is the support model for ESX, vSphere, vSAN, NSX level?
So the support model is defined by in such a way that if in case you have a problem with the Oracle Cloud VMware Solution, SDDC, or anything related to Oracle Cloud VMware Solution, when I say Oracle Cloud VMware Solution, it comprises of vSphere, NSX, and vSAN. Then you raise a ticket with Oracle. Oracle has the dedicated SMEs, a team which manages Oracle OCVS. They would help you out. In case they need assistance from VMware, they in turn would contact VMware for any engineering assistance, any higher tier of escalations that they require. Oracle would be your first and the last point of contact. For any attached solutions that you have, like Horizon, ARIA, and SRM, and any other solutions which you add on by with OCVS, for those solutions, you would have to contact VMware.
Okay, and I went and looked at PCA. Looks like there's a private cloud appliance, an Oracle private cloud appliance. Does that resonate?
You can. We would have to look at what specific appliances that you're looking for, but you can move any specific appliances which you're running on VMware as of today on your vSphere platform. There is no restriction to move those appliances to your OCVS SDDC.
Okay. I think that brings us to the end of our questions. So thanks so much. Clearly, the harmonious orchestration of benefits and features of OCVS that Pratik told us about ring out like a symphony that we remembered for a long time. Thanks so much, Pratik. For those of you going to VMware Explore, I hope you have a great conference. Take time to talk with people you don't already know. It's one of the best parts of attending a conference in person. And please check out the VMware TAM Customer Webinar YouTube channel and watch for the invite to the September webinar where you can learn more about ARIA Automation Config. Cheers.
Thank you.